Yeah, that's basically.
Well, thank you everybody for being here today. My name is Maria Pina and my partner is Jared Thorne. We represent the undergrad program of industrial design at the University of Houston. And today we want to talk to you about a project that we finished last year in conjunction with the College of Technology. So it was a multidisciplinary project, and this is how it starts. The machine that you see right here is an air oxygen blender that you see at hospitals. It mixes air and oxygen, obviously, from the source, and then it is put into preemie babies or people born in a hospital. The problems that we found out in the first place is the nurses and the patient ratio. We have very few nurses and many kids that need to be taken care of 24/7. And the problem, if something is not taken care of correctly, can cause blindness on the child or brain damage or even death.
The project took off before we got involved. The College of Technology actually worked on this project for a semester before we got involved. The diagram to the left is kind of an edited depiction that I did of their original layout drawing for this device. And so they were using a lot of prototyping electronic components. The model on the right is what they produced at the very end of the project. And this is a functional prototype. Obviously the aesthetics are not the most optimal, but the idea here is that they were able to work out all the electronics and all the software and everything like that. And we were able to talk to them about the usability and the, kind of what the software should be goal towards, where they were really focused in the very nitty-gritty and actually getting that to function. Here is an overview of the system, and so it took a couple trials and error for when we were introduced to the project for us to understand it. So this is kind of how we depicted it, and it turned out to be a really good diagram to use for situations like this. And as you can see, what happens here is, like Maria was mentioning, the air and oxygen come from two separate sources. They go into the blender here, and then they go into the patient. Now, at the foot, you see that there's a sensor that will measure the oxygen in their blood level through light, which is pretty cool. Typically, in a scenario now, that sensor will go back to a monitor and it'll just be feedback and it'll tell you where the patient is at. And so you've got to use your attention skills as a nurse or a doctor, most of the time the nurse, to understand what that signal is and whether that's good or bad. In this system here, steps 3 and 4 are repeated constantly to check. So the air's gone to the patient, then the sensor goes to the machine, the Scor machine up there, and that tells it, is it good or bad, and then it adjusts the machine below it, and it constantly feeds back.
So we were basically able to take a task that had to be performed manually, but nurses many times repeatedly over the day on every patient, and then make it into a very easy to use and understand machine that would be adjusted into existing systems within a hospital. And it was designed for maintenance, since it is required for them to be repaired or inspected every 2 years. And it is very easy to use in order to reduce mistakes and slips within the hospital environment, and also to make a little bit of a more peaceful environment for people who are repeatedly at the hospital. Once again, we come from the University of Houston, and we would like to hear your feedback. Thank you very much.